Bismillahirrahmanirrahim. Experiment number 4. Ionic reactions and the precipitation reactions. In this experiment, the student will react to ionic compounds in aqueous solution to observe the precipitation reactions. Now, ionic compounds consist of positive charge ion, which called cation, and negative charge ion, which called anion. So the ionic compounds again consist of positive charge ion, which called cation, and negative charge ion, which called anion. Now the ions, two types. Some ions are monoatomic ions. Monoatomic ions consisting of single atom with positive or negative charge, like for example Na plus, Ca2 plus, Cl minus, O2 minus. So monoatomic ions again consisting of a single atom. And some ions are polyatomic ions. Polyatomic ions consisting of a cluster of atoms with overall charge positive or negative, like for example ammonium ion NH4 plus, nitrate ion NO3 minus, carbonate CO3 2 minus, sulfate SO4 2 minus, and also phosphate ion PO4 3 minus. Example: sodium chloride ionic compound NaCl consists of positive charge ion, which is Na cation, Na plus, and negative charge ion, which is Cl minus, anion Cl minus chloride. Now here the shape of NaCl in solid state, regular cubic shape. Now when you add the NaCl in aqueous solution, NaCl soluble in aqueous solution. So when you add the NaCl again in water in the aqueous solution, NaCl will be dissociated to Na plus and Cl minus. So Na plus and the Cl minus will stay in the solution as free ions. Now you can use table number 1, solubility rules for ionic compounds in aqueous solution. So you can use the solubility rules to know which ionic compounds are soluble in water and which ionic compounds are insoluble in water. Rule number 1. All common compounds of group 1A like lithium Li plus, sodium Na plus, potassium K plus, and ammonium ion NH4 plus are soluble. So for example, NaCl soluble, KCl soluble, ammonium chloride soluble, ammonium hydroxide soluble. Rule number 2. All common nitrate NO3 minus, acetate C2H3O2 minus, and most perchlorate ClO4 minus are soluble. So nitrate, acetate, perchlorate soluble. So for example, silver nitrate soluble, sodium acetate, sodium perchlorate. Rule number 3. All common chlorides Cl minus, iodide I minus, and bromide Br minus are soluble, except you have here exception. Rule number 3, exception, except with Ag plus, lead Pp2 plus, and mercury Hg2 plus. So chloride again, bromide, iodides soluble except with silver, except with lead, except with mercury. So for example, AgCl insoluble, for example lead iodide insoluble, for example mercury chloride insoluble. Rule number 4. All common sulfate SO4 2 minus are soluble. So sulfate SO4 2 minus soluble except with calcium, except with strontium, barium, and lead, and also silver. So sulfate soluble except with calcium, strontium, barium, lead, and silver. So calcium sulfate insoluble, strontium sulfate insoluble, barium sulfate insoluble, lead sulfate insoluble, and also silver sulfate insoluble. Rule number 5. All metal hydroxide, metal with OH, like for example copper hydroxide, iron hydroxide, are insoluble. So metal with hydroxide insoluble except with group 1A, and also ammonium ion soluble. Now hydroxide with calcium, hydroxide with strontium, barium, slightly soluble. Rule number 6. All sulfide ion S2 minus are insoluble. So sulfides insoluble except with group 1A and also with the ammonium ion, with the calcium, strontium, and barium soluble. So sulfide again, sulfides S2 minus insoluble except with group 1A like sodium, potassium, lithium, and also with the ammonium ion, with the calcium, with strontium, and the barium. The last rule, all carbonate SO3 2 minus and phosphate PO4 3 minus are insoluble except with group 1A and also with the ammonium ion. So carbonate, phosphate insoluble except with group 1A and with the ammonium ion soluble. Okay, so you can use again solubility rules to know which ionic compounds are soluble and which ionic compounds are insoluble. So now the precipitation reaction. The precipitation reaction is chemical reaction where one of the products is a precipitate. So precipitation reaction, chemical reaction, one of the product is precipitate. So what's the precipitate? Precipitate is a solid substance that insoluble in water. So insoluble in water and also colored substance falls out of the solution or stay down in the solution. So the precipitate again, solid substance, insoluble in water, colored substance falls to the bottom of the container, okay, or stay down sometimes. So like for example AgCl, calcium carbonate, iron hydroxide. Okay, so the precipitate again, solid substance, colored substance, insoluble substance falls out of the solution or to the bottom of the container, and also the precipitate may be stay down. Now the precipitation reaction is a type of double replacement reaction or ion exchange reaction. So the precipitation reaction is type of double replacement reaction or ion exchange reaction. So what's the double replacement reaction? Double replacement reaction or ion exchange reaction between two ionic compounds in aqueous solution. Cations and anions in the reactant change partners in the product. Okay, so again, double replacement reaction between two ionic compounds in aqueous solution, cations and the anions in the reactant change partners in the product. So here for example, this ionic compound consists of cation A and anion B, and here cation C and anion D. So change partners. So A with cation A with anion D and cation C with anion P. Okay, this is the product. Now if there is any precipitate in the product, the reaction called precipitation reaction. Example. I have here two solutions. Solution number one, flask number one, I have lead nitrate. I have solution number 1, lead nitrate. Solution number 2, I have potassium iodide. According to solubility rules, lead nitrate soluble and potassium iodide also soluble. So I have lead nitrate soluble in aqueous solution and potassium iodide also soluble in aqueous solution. Now I will react. I will add lead nitrate into potassium iodide. So I will react lead nitrate with Ki, two ionic compounds in aqueous solution. Automatic, you will obtain double replacement reaction. What does mean double replacement reaction again? Cations and the anions in the reactant change the partners in the product. So lead nitrate, the cation is lead and anion nitrate, nitrate ion. Here potassium iodide, the cation potassium and anion iodide. So lead, double replacement, lead with iodide to produce lead iodide, and the potassium with nitrate to produce potassium nitrate. So the product lead iodide and potassium nitrate. Lead iodide, according to solubility rules, insoluble substance. Rule number 3 again. All common iodides are soluble except with lead. So lead iodide insoluble. Now potassium nitrate soluble. So the potassium ion and nitrate ion will stay in the solution as free ions, and also you can call these ions are spectator ions. So spectator ions, ions that stay in the solution as free ions, ions that do not involve to produce the precipitate. So you will observe here solid substance, yellow precipitate. You will observe yellow precipitate, which is lead iodide. Okay? Now, chemical equations. There are 3 types of chemical equations: molecular equation, complete ionic equation, and net ionic equation. Note, precipitation reaction should have a net ionic equation. So be careful here. Note, precipitation reaction should have a net ionic equation. This is the precipitate. This is the formula how to write a net ionic equation. This is the precipitate. Example: cation A and the anion B. So net ionic equation shows only ions that involved in the precipitate only. So cation A, this is the charge, N plus, and anion B, M minus, produce the precipitate. So this is the general formula how to write net ionic equation. Again, net ionic equation shows only ions that involved in the precipitate. Example: the reaction between silver nitrate and sodium chloride. Sodium chloride. How can you write a molecular equation? Now, molecular equation shows the molecular formulas of the reactants and with physical status. So write the equation with molecular formulas and also with physical status. So silver nitrate, this is the formula, molecular formula for silver nitrate, AgNO3. This is soluble, so the status aqueous. Plus sodium chloride, the molecular formula for sodium chloride NaCl. This is soluble also, so aqueous status. So reaction between two ionic compounds in aqueous solution. Double replacement. Ag with Cl, chloride, and sodium with nitrate. So the product AgCl and sodium nitrate, NaNO3. AgCl, this is insoluble substance. According to solubility rule, again AgCl insoluble. Rule number 3, all chlorides are soluble except with Ag. So this is solid. Now, sodium nitrate, NaNO3, this is soluble, so the status aqueous. So this is the molecular equation, balanced chemical equation. Now, how can you write a complete ionic equation? Complete ionic equation shows ions exist in the reaction mixture. So all ions. So write the equation with all ions. Ions exist in the reaction mixture. So here, silver nitrate, you have cation Ag, the charge of Ag plus, aqueous, and anion nitrate NO3, aqueous with the status plus. Sodium chloride, I have sodium cation Na plus, aqueous, and chloride Cl minus, aqueous. Produce. Here I have insoluble substance, so write it as it is. Don't write it as ions. So AgCl solid plus. Here sodium nitrate, I have sodium Na plus, aqueous, plus NO3, aqueous. So write the equation as ions. So what do you think here? The precipitate is AgCl. This is the precipitate, and this is the formula of the precipitate, AgCl. Now, what's the spectator ions? Again, spectator ions, ions that do not involve in the precipitate, ions that stay in the solution as free ions. So the sodium ion and nitrate ion are spectator ions. Ions do not involve in the precipitate. Here, how can you write a net ionic equation? Net ionic equation again shows only the ions involved in the precipitate formation without the spectator ions. So only shows ions involved in the precipitate formation. So I have precipitate AgCl. So AgCl, the precipitate. So ions that involved in AgCl, Ag plus, and Cl minus. So Ag plus aqueous plus Cl minus produce AgCl solid. In this experiment, we are going to examine the reaction between copper ion Cu2 plus with anions chloride Cl minus, hydroxide OH minus, and iodide I minus, tetraborate PO4 O7 2 minus. Write down the chemical equations of the reactions that showed a precipitate formation. Identify the copper salt that are insoluble in water and the spectator ions. The materials: sodium chloride NaCl, this is soluble. Copper sulfate CuSO4, also soluble. Sodium hydroxide NaOH, also soluble. Potassium iodide Ki, also soluble. And also sodium borate Na2PO4 O7, soluble. And 4 test tubes. Experiment procedure: add approximate volume 1.5 ml of copper sulfate in 4 test tubes. So add 1.5 ml approximate volume copper sulfate in 4 test tubes. In test tube number 1, add 1.5 ml sodium chloride. So the first reaction is between sodium chloride and copper sulfate. So is there any precipitate? So yes or no. If you observe any precipitate, answer yes or no. If you observe precipitate, answer yes. If there is no any precipitate, answer no. So molecular equation. Again, molecular equation shows the molecular formulas. So copper sulfate CuSO4, this is soluble aqueous, plus sodium chloride NaCl aqueous, double replacement copper with chloride, sodium with sulfate to produce copper chloride aqueous and sodium sulfate aqueous. Now to balance this equation, so the coefficient here should be 2. So 2 NaCl. So now this equation balance chemical equation. So now write the complete ionic equation. Write the equation as ions. Here I have copper ion, so Cu2 plus, and sulfate SO4 2 minus aqueous, plus I have here sodium and chloride. So I have 2 sodium 2 Na plus aqueous and 2 chloride 2Cl minus aqueous. Produce copper chloride, this is aqueous. So I have here copper, 1 copper, and I have 2 chloride, so 2Cl aqueous. Here sodium sulfate aqueous, also soluble. So I have 2 sodium 2 Na plus, and I have 1 sulfate. And also this equation is balanced chemical equation. The net ion equation, again, net ion equation shows ions only involved in the precipitate. So here in this reaction, the product here soluble and this is soluble. So there is no any precipitate. So no net ionic equation. In test tube number 2, add 1.5 ml sodium hydroxide. So reaction number 2 is between sodium hydroxide and copper sulfate. So is there any precipitate? Answer yes or no. Now the molecular equation shows again molecular formulas. So copper sulfate CuSO4 aqueous plus sodium hydroxide aqueous NaOH aqueous, double replacement copper with hydroxide, sodium with sulfate. So the product is copper hydroxide and sodium sulfate. Copper hydroxide, according to solubility rules, insoluble metal hydroxide. So this is insoluble solid, and sodium sulfate soluble, so aqueous. So now complete ionic equation. Write equation as ions. So here copper sulfate, I have cation copper Cu2 plus aqueous, and I have sulfate SO4 2 minus aqueous. I have here cation sodium Na plus and OH minus hydroxide. I have 2 Na, 2 sodium, so 2 Na plus and 2 hydroxide, 2OH minus. The state is aqueous. Aqueous produce. This is solid, insoluble substance, so write it as it is, copper hydroxide, solid, plus here I have cation, sodium and sulfate here, SO4 2 minus. I have 2 sodium, so 2 Na plus and 1 sulfate, so SO4 2 minus. Aqueous. So in this reaction I have precipitate, which is copper hydroxide. So this is the formula of the precipitate. So the formula of precipitate CuOH2. So this is the formula of the precipitate. Here, what's the spectator ions in this reaction? The spectator ions in this reaction, sulfate ion and sodium. Sodium and sulfate ion, spectator ions. Ions do not involved in the precipitate. So now, net ion equation. To write a net ion equation, again, a net ion equation shows ions that involved in the precipitate. So the precipitate is copper hydroxide. This copper hydroxide consists of copper, cation, the charge of copper, Cu2 plus, aqueous, and hydroxide ion, OH minus. So copper 2 plus plus OH minus produce copper hydroxide. I have here 2 hydroxide, so the coefficient here should be 2. So this is now balanced chemical equation. In test tube number 3, add approximate volume 1.5 ml potassium iodide. So reaction number 3 is between potassium iodide and copper sulfate. So is there any precipitate, yes or no? Molecular equation shows again molecular formulas. So potassium iodide Ki aqueous soluble plus copper sulfate CuSO4 aqueous soluble, double replacement potassium with sulfate and copper with iodide. So the product copper iodide solid, Cui2S solid, and potassium sulfate aqueous. So to balance this equation, the coefficient here should be 2, because you have here 2 iodide. So now 2 iodide, here you have 2 potassium, so 2 potassium. So this is the molecular equation. Now complete ionic equation. Write the equation as ions. You have potassium here, cation and iodide. You have 2 potassium and 2 iodide, so 2K. The charge is plus, aqueous, and 2 iodide, 2I minus, aqueous, plus. You have here 1 copper, the charge of copper 2 plus, aqueous, and sulfate, 1 sulfate, SO4 2 minus, aqueous. Produce, this is precipitate, so write it as it is, copper iodide solid. Here you have 2 potassium, 2K plus, aqueous, and you have 1 sulfate, SO4 2 minus. So this is the complete ionic equation, also balanced chemical equation. Write the net ion equation. To write a net ion equation shows ions that involved in the precipitate. So the precipitate is copper iodide. So this is the formula of the precipitate. The formula of precipitate Cui2. So this is the precipitate. This precipitate consists of copper, the charge of copper 2 plus, and iodide plus I minus. You have here 2 iodide, so the coefficient here should be 2. So copper 2 plus 2 I minus produce copper iodide Cui2. So this balanced chemical equation also. Here in this reaction, the precipitate is copper iodide. This is the precipitate, and the spectator ions potassium and sulfate. Potassium ion and sulfate ion, spectator ions. Now, in test tube number 4, add 1.5 ml sodium borate. So reaction number 4 between sodium borate and copper sulfate. Is there any precipitate? Yes or no? Molecular equation: copper sulfate plus sodium borate, aqueous, produce a replacement: copper with borate and sodium with sulfate, produce copper sulfate and sodium, copper borate here and sodium sulfate, aqueous. So this is the precipitate. This is the precipitate, solid. Complete ionic equation. Complete ionic equation. You have here copper, one copper and one sulfate, copper, sulfate plus sodium and borate ion, produce, this is solid precipitate, and sulfate and sodium. Here you have sodium and sulfate. So the precipitate here is copper borate, and the spectator ions sulfate and sodium. So sodium ion and sulfate ion are spectator ions. Here, net ion equation. Net ion equation again shows ions that involved in the precipitate. So this is the precipitate. The ion here consists of copper, the charge of copper 2 plus, and borate ion, the charge of borate ion 2 minus. So copper ion plus borate ion produce copper borate. This is balanced chemical equation. So this is the net ion equation. Now the observation. Here you have 4 stew for reaction. Reaction number 1, NaCl with copper sulfate, sodium hydroxide with copper sulfate, potassium iodide with copper sulfate, and sodium borate with copper sulfate. Here write, is there any precipitate? Just write yes or no. In reaction number 1 there is no any precipitate, so there is no precipitate, no. Here there is a precipitate which is copper hydroxide, so here yes. Here there is a precipitate which is copper iodide, so yes. And here there is a precipitate which is copper borate. Here write the formula. Just write the formula. There is no precipitate, so there is no formula. Here the formula of the precipitate here is copper hydroxide. Copper hydroxide. The formula CuOH2. So here the precipitate is copper iodide, so the formula is copper iodide, and here the precipitate is copper borate, so the formula CuP4O7. Here guys, examples for precipitation reactions. Again, the precipitate, solid substance, colored substance, insoluble substance, falls out of the solution or stay down. So you can see examples here for precipitation. So here you can see the precipitate, yellow precipitate here, also white precipitate, yellow precipitate, white precipitate. So the precipitate again will stay down or falls out of the solution. Okay, so here examples for precipitation reactions. Now if you have any questions, please contact me in my email, or you can call me in my extension, which is 45495. My extension again 45495, or you can contact me in my email. Thank you.